Hello, my dear mechanical students. How are you all? What's up? कैसे हैं सब लोग? Please, guys, do join me fast. And those who are already here, respond through the comment section. This is Chandrashekhar, welcoming you all to the India's largest, the best, and your favorite live learning platform. That is BYJU'S Exam Prep. So today is the last session for thermal radiation. That is the radiation shield. We are going to discuss about the radiation shield in today's session. So the duration of the session will be around 45 to 60 minutes. And first of all, we will discuss the assignment question and then we will proceed with our conceptual part. But before I start, please guys do join me and let me know if my audio and video quality are fine, so that we can start our session on time. Those who are watching me live, please respond through the comment section. Am I audible and visible to everyone perfectly? So, and do let me know, what do you understand by radiation shield? Why do we use the radiation shield? Quickly, let me introduce myself for those who are meeting me for the first time. My name is Chandrashekhar. I am a mechanical engineering graduate from IIT Delhi. And also, I have cleared engineering services examination. I have worked in SAIL. From last 9+ years, I am into teaching, guiding the students, mechanical engineering students who are preparing for various competitive examination. And there is a email ID mentioned over the screen. You can always contact me through the mail ID, official mail ID, if you have anything to discuss. And it is always preferred to be part of my Telegram group, Mechanical by Chandrashekhar. And the link is also mentioned over the screen. Once you join me on the Telegram, you will get all the notifications, exam notifications, and you will be provided with the study notes and PDF of all my free sessions. And there will be doubt clearance also. So it is always be beneficial to become part of my Telegram group, that is Mechanical by Chandrashekhar. And other than the free sessions, BYJU'S also provide the students the paid classes. You can be part of our paid course to achieve your desired rank in GATE 2023 examination. I have not seen any comment yet. Are you guys there? Knock knock. Are you guys physically, mentally, as well as emotionally present to the class? Keep your notebook, calculator and pen along with you for attending the class with your full dedication, with your full honesty, with your full energy, full power. Try to gain maximum out of these free sessions. Keep on talking to me, keep on asking your doubts, keep on giving your opinion, share your knowledge. That is how the knowledge improvement takes place. All right. And those who have joined this session for the first time, those who have come to our YouTube channel for the first time, do subscribe our YouTube channel. Then you will be getting all the notifications of free sessions which we bring for the students' benefit from time to time. Shall we start? Are you all ready? What we are going to discuss in next 45 minutes. Hi Sairam, good evening, welcome. Where are others? So first of all, we will solve the assignment question, the homework questions. I hope you have tried them as per your understanding. Still, if you are facing any difficulty, you can always let me know through the comment section. I will solve those questions first. Then we will talk about the 3 surface enclosure. We have discussed about the 2 surface enclosure, how to draw the circuit diagram. Now we will be talking about the 3 surface enclosure, how to draw the electrical analogy circuit diagram and how to analyze. Then we will move to the another concept, that is refractory medium. What is the refractory medium? Anybody is having any doubt? Anything? Anybody is having any information, any knowledge about refractory medium? And lastly, we will be talking about the radiation shield. So this will be our agenda for today's discussion. All right. So shall we start? I hope everyone is completely ready to explore the beautiful session on thermal radiation And day after tomorrow we will be meeting again at 11 a.m. and we will be having the Menti war for theory of machines as well as heat transfer. The topic for the heat transfer will be complete thermal radiation. Okay, so let us start with the question discussion. This was the first question. The radiative heat transfer rate per unit area between the two plane parallel gray surfaces. Emissivities are same. Epsilon 1 is equal to epsilon 2 is equal to 0.9. Maintained at temperature T1 400 and T2 300. Then what will be the radiation heat flux? We know Q dash is equal to sigma into T1 to the power 4 minus T2 to the power 4 upon twice of epsilon minus 1. Do you remember this formula for two very large parallel plates? A1 is equal to A2 is equal to A and F1 to 2 is equal to 1 because they are very large parallel surfaces. If you put all the parameters, the unit will be watt per meter square. If you put all the parameter in the equation which we have already developed in the last class, you will get option B as the right answer. What is the answer to this question? Did you get the option B? Hi Sairam, I hope you have got option B as the answer, right? The next question, again two large parallel gray plates with a small gap exchange radiation at the rate of 1000 watt per meter square when their emissivities are 0.5. By coating one plate, its emissivity is reduced to 0.25, but the temperature remains unchanged. The new rate of heat exchange shall become. So Q dash is given by sigma into T1 to the power 4 minus T2 to the power 4 upon 1 by epsilon 1 plus 1 by epsilon 2 minus 1. That is the original expression when we consider A1, A2 is equal to A and F1 to 2 is equal to 1. So this is the expression because the temperatures are still the same. Sigma is the Stephen Boltzmann constant. So Q dash is inversely proportional to 1 by epsilon 1 plus 1 by epsilon 2 minus 1. So if we want to write Q dash new divide by Q dash old, then we will have 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1 old upon 1 upon epsilon 1 plus 1 upon epsilon 2 minus 1 new. So if we write old expression, so it is 1.5 plus 1 by 0.5 minus 1 is the numerator. Denominator will be 1 upon 0.5 plus 1 upon 0.25 minus 1. This will be the expression. So if you solve this, then it will be 3 by 5. Q dash new upon Q dash old will be 3 by 5. So Q dash new will be equal to Q dash old into 3 by 5 will give you the answer. 1000 multiplied by 3 by 5, that will give you 600 watt per meter square, isn't it? That will give you 600 watt per meter square. Option B, again option B is correct. Now the next question, I hope it is clear to everyone. The next question, this question was actually very confusing. So many students have got option D as the answer, but I had told the students on my Telegram group that option A will be the correct answer. How? Look, the question is, there are two parallel plates, very large isothermal parallel plates. Upper plate is a black surface and the warmer one maintained at 727 degrees Celsius, and the plate 2 is diffuse and gray surface with an emissivity of 0.7 and it is kept at 227 degrees Celsius. Now we need to find out the irradiation in kilowatt per meter square for the upper plate. This is the diagram. We can say epsilon 1 is equal to 1, T1 is equal to 727 plus 273 Kelvin, isn't it? And epsilon 2 is equal to 0.7, T2 is equal to 227 plus 273 Kelvin. Temperature has to be Kelvin only, in Kelvin. Now, if we want to find out the irradiation for the surface 1, try to understand. Very important. If we want to find out the insolation for surface 1, the surface 1 will not be the source of radiation. If we want to find out the insolation for surface 1, all the other surfaces other than the surface 1 will be the source of radiation. Then the amount of radiation incident on surface 1 will be the insolation or irradiation. So it should not be treated as a source. As I told you, if you were part of my radiation definition class, there I told the students that irradiation for a particular surface does not depend on its surface temperature, does not depend on its surface condition like roughness and the color. It does not depend on the material of that particular surface. So irradiation for surface 1 is neither be a function of temperature T1 nor it will be a function of the surface condition of surface 1. It means all the other surfaces other than the surface 1 will be the source of radiation. Are you getting it? There is only one surface, that is surface 2, which will be the source of radiation. So if we want to find out the irradiation, have you understood it? I will tell you where the students committed mistake. If we want to find out the radiation, if I ask you the amount of radiation incident on surface 1, if we want to find out the radiation incident on surface 1, Q1 incident, if we want to calculate Q1 incident, that is equal to G1 into A1, isn't it? That will be defined by the radiation emitted by surface 2, because this will be the source of radiation. So the irradiation for surface 1 depends on the temperature of surface 2, depends on the surface condition of surface 2, depends on the material of surface 2. So we can say, can we say the it will be Q2 to 1 emitted. It will be Q2 to 1 emitted. Q1 incident will be equal to Q2 to 1 emitted. Do you guys understand this? G1 will not be equal to EB2. G1 will not be equal to EB2. G1 into A1. The unit is what? Then only they can be equated. It is the energy conservation. So whatever the radiation incident on surface 1, that is G1 into A1, should be equal to Q2 to 1 emitted. Now we can say G1 into A1 will be equal to, how to write Q2 to 1 emitted? Do you agree it is F2 to 1? Because all the radiation emitted by surface 2 may not reach a surface 1. There is a possibility the radiation may lost to the surrounding. So we need to introduce the shape factor from 2 to 1 into Q2 emitted. Do you agree or not? G1 A1 will be equal to F2 to 1 into Q2 emitted. And second surface is non-black surface. So do you agree it will be F2 to 1 into, from the Stefan-Boltzmann law, we can say epsilon 2 into sigma into T2 to the power 4 into A2. That is G1 into A1. And if we want to find out G1, then G1 will be equal to, we can take this together. We can say A2 F2 to 1 upon A1 into epsilon 2 into sigma into T2 to the power 4. Do you agree or not? And A2 F2 to 1 upon A1 is nothing but F1 to 2, isn't it? A1 F1 to 2 is equal to A2 F2 to 1 into epsilon 2 into sigma into T2 to the power 4. If you will do this, watt per meter square. If you will solve this, F1 to 2 will be equal to 1. What is the value of F1 to 2? We can say, as it is the two surface enclosure, F1 to 1 plus F1 to 2 is equal to 1. F1 to 1 will be 0. So F1 to 2 is equal to 1. Put the value of F1 to 2 as 1. Epsilon 2 is 0.7 and sigma 5.67 into 10 to the power minus 8, and T2 is taken as 227 plus 273. Then you will get option A as the correct answer. What students have done is, they have considered the radiation emitted by the surface 1, which reaches to 2 and reflected back to surface 1. Students have considered this radiation also. That will not be the part of irradiation for surface 1. The radiation emitted by the surface 1 will not be the part of irradiation for surface 1. Surface 1 cannot be the source of radiation. If we want to find out the irradiation for surface 1 cannot be the source of radiation. Do you get it? So the irradiation on surface 1 will never be the radiosity from surface 2. It will not be the radiosity. If there is third surface, try to understand. If there is a third surface 3, the radiation leaving the surface 3, striking to surface 2 and then reflected towards surface 1 will be the part of irradiation for surface 1. If there are 3 surfaces 1 to 3, and if we want to find out the irradiation for surface 1, then the source of radiation will be considered as 2 and 3 only, not 1. Do you get it? Otherwise, if you will start considering the radiation from 1 and reflected by 2 as the part of irradiation for surface 1, then it will create a huge problem to calculate the irradiation for surface 1 if the surface 1 is also a non-black body. Look, if surface 1 is non-black body, in the second case, the surface 1 is also a non-black body. So if you want to find out the irradiation for surface 1 and surface 1 is non-black body, then what will happen? Then you will start calculating the radiation leaving the surface 1, reflected by 2, reaches to 1. That will be part of irradiation. Then it will also reflect the radiation. 2 will also reflect the radiation. Then again it will be considered as part of irradiation. Then reflected by 2, reflected by 1, and then again reflected by 2. So it will not be possible to calculate the irradiation for surface 1 if the surface 1 is taken as the source of radiation. I hope it is clear to everyone. So if we talk about the second part is very simple. The epsilon 1 is 0.8, the net radiation heat exchange between plate 1 and 2. So Q1 to 2 net, or Q dash 1 to 2 is sigma into T1 to the power 4 minus T2 to the power 4 upon 1 by epsilon 1 plus 1 by epsilon 2 minus 1. That will give you the answer. Option D is the correct answer. That will give you the answer as option D. And in this case, what will be irradiation for surface 1? So whether the surface 1 is black or non-black, it does not matter when we calculate the irradiation for surface 1. So irradiation for surface 1 will remain same. Whether surface 1 is a black surface or non-black surface, the irradiation for surface 1 will remain same. I hope it is clear to everyone. Any doubt? Please acknowledge if you have understood it. So the answer to the first part is 2.5, but answer to the second part is 31.7. And irradiation for surface 1 in both the cases will remain same. Because F1 to 2 will remain same, epsilon 2 is also same value, T2 is also the same value. So it will not impact the irradiation for surface 1. Now if it is a 3 surface enclosure, 3 non-black surface enclosure, can you just let me know how many thermal resistance will be there in the circuit diagram? Can you draw the circuit diagram for the given situation? If it is a 3 non-black surface enclosure, all the surfaces are non-black. Emissivities are epsilon 1, epsilon 2 and epsilon 3. And areas are A1, A2, A3. Temperatures are T1, T2, T3. It can be treated as an enclosure. So how many thermal resistances will be there? For this figure, the total number of radiation thermal resistance, can you just let me know? Can anybody let me know? The total number of thermal resistances. Waiting for your response. I want you guys to draw the circuit diagram. Can you draw? Yes. The total number of radiation thermal resistance for the given figure. Yes, Sairam, very nice. There will be three surface resistances because all are non-black, and there will be three space resistance. One space resistance between 1 to 2, another space resistance between 1 to 3, and the third space resistance is between 2 and 3. So the circuit diagram will look like this. This is how the circuit diagram will look like. R1 is the surface resistance for 1, R2 is the surface resistance for 2, R3 will be the surface resistance for 3. And R12 is the space resistance between 1 and 2, and R123 is the space resistance, and R223 will be again the space resistance. How to write Q1? This is net. These are net. Q1 net. This is how you can write Q2 net. This is Q3 net. This is how the circuit diagram. There will be a closed loop. You will have a loop also. So Q1 net is equal to EB1 minus J1 upon R1. Similarly, Q2 net will be equal to EB2 minus J2 upon R2, and Q3 net will be equal to EB3 minus J3 upon R3. These are the surface resistances. Surface resistance are already mentioned here. R1, R2 and R3 are the surface resistances for the non-black surfaces. And again, if we want to write Q1 to 2, so can we write Q1 to 2 is equal to J1 minus J2 upon R1 to 2? Isn't it? That is equal to minus Q2 to 1. Q1 to 2 is J1 minus J2 upon R1 to 2. That is the space resistance between 1 and 2. Similarly, Q1 to 3 can be written as J1 minus J3 upon R13. That is equal to minus Q3 to 1. Isn't it? And also we can write Q2 to 3. That is equal to J2 minus J3 upon R2 to 3. That is equal to minus Q3 to 2. Do you get it? This is how we can write. And also these are the things. And also for the non-black surface, 3 non-black surface enclosure, for any node or the junction, these are the 3 junctions. For any junction, net heat transfer to any junction or the node must be equal to 0. Is equal to 0. Net heat transfer to the node according to the circuit diagram. According to the circuit diagram, net current at the junction will be equal to 0. Net current flow to the junction will be equal to 0. So can we say Q1 net is equal to Q1 to 2 plus Q1 to 3, isn't it? Q1 to 2 plus Q1 to 3 at node J1. Similarly for node J2, can we write Q2 net is equal to Q2 to 1 plus Q2 to 3, 2 to 1 plus 2 to 3, and Q3 net is equal to Q3 to 1 plus Q3 to 2, isn't it? At any junction, the net heat flow must be 0. There are 3 junctions. These are the junctions. J1, J2, J3 are the junctions. These are the junctions. If we add these two, then we can say Q1 plus Q2 is equal to, if we add Q1 to 2 is same as minus Q2 to 1. So they will get cancelled out. So it will be Q1 to 3 plus Q2 to 3, isn't it? Because Q1 to 2 is equal to minus Q2 to 1. Q1 to 2 can be replaced by minus Q2 to 1. If we add them, then they will get cancelled out. And then if we add these together, this and this, if we add them, then what we will get? Then we will get Q1 net plus Q2 net plus Q3 net on the left hand side will be equal to right hand side will be, if you see the right hand side, Q3 to 1 is equal to minus Q1 to 3. Q3 to 2 is equal to minus Q2 to 3. So it will be 0. Isn't it? That is how you can modify the circuit diagram. You can solve the circuit diagram. If you know these basic things, you can always use the basic concept of circuit diagram to solve. I hope it is clear. Anybody is having any doubt? Now let us continue our discussion. Let us move to the refractory medium or refractory surface. The refractory surface is also called as re-radiating surface. Do you know what is refractory surface? It is also called as non-participating surface. It is also called as insulated surface because it is not participated in the radiation exchange. So the refractory medium or refractory surface can also be called as re-radiating, non-participating or insulated surface. What is refractory surface? The surface must lose as much radiation energy as it gains, and thus Q net is equal to 0. For a refractory surface, the net heat exchange will be 0. This is the irradiation, the radiation gained by the surface. This is the refractory surface, let us say. This is the refractory surface. Radiation gained is G and the radiation leaving is J. So according to the definition of refractory medium, G is equal to J. Whatever the radiation gained by the surface is equal to the radiation lost by the surface. So we can say it is not participating. We can say whatever the radiation incoming is equal to outgoing. Incoming is equal to expense. It is not participating. But the surface resistance, what about the surface resistance for this? Surface resistance is 1 minus epsilon upon epsilon A. That is non-zero. There is a difference between refractory surface and black body. Refractory body and black body, there is a difference. Surface resistance is non-zero because neither epsilon is equal to 1 nor area is very large. This is EB, this is J. Only Q net will be equal to 0. Q net will be equal to 0. Are you getting it? There is a difference between refractory surface and black surface. Black body is having 0 surface resistance. The surface resistance for the black body is 0. But the refractory surface will not have 0 surface resistance. But it is having the heat transfer to be 0. It is not participating. So we can say Q net by area is equal to EB minus J upon surface resistance. Because this term is equal to 0. So we can say as Q net is equal to 0 implies EB will be equal to J is equal to sigma into T2 to the power 4. Surface resistance will not be 0. Q net will be 0 for the refractory surface. It is non-participating. It is non-participating. It is not participating in the radiation analysis. Is this clear to everyone? Is the concept clear? Refractory surface, non-participating, re-radiating, insulated. Q net will be 0. There is no heat flow in the circuit. So there is no significance of the surface resistance, even though the surface resistance is non-zero. So it is not a black body, but the surface resistance is not coming into the picture in the analysis. We can remove this resistance because there is no heat flow in this part of the circuit diagram. Then we can remove that part from our analysis. Can you draw the circuit diagram for this given example? There are 3 surfaces and we can consider it as enclosure. Surface 1 is non-black, emissivity is given. Surface 2 is black, emissivity is equal to 1. Surface 3 is insulated or re-radiating. Surface 3 is re-radiating. There is 3 surface enclosure. One is non-black surface, non-black body. Another is black body, and the third one is insulated or re-radiating or non-participating. Can you just let me know how many thermal resistances will be there in the given circuit? The number of thermal resistances. Once you draw the circuit diagram correctly, then you will be able to analyze the radiation correctly. So the first step is to understand how to draw the circuit diagram. That is very, very important. The total number of resistances will be how many? Can you just let me know the total number of thermal resistances for this? No doubt surface resistance will be 3. Sorry, space resistance. Space resistance will be 3. And how many surface resistances? Number of surface resistance. Black body will not have any surface resistance. The black body will not have any surface resistance. Non-black body and the insulated medium will be having the surface resistance. So number of surface resistance will be 2. So how to draw the circuit diagram? This is, let us say, EB1. So there will be total 5 thermal resistances. This is EB1. One resistance. This is J1 because it is non-black. This is R1. R1 is equal to 1 minus epsilon 1 upon epsilon 1 A1. And then between J1 and J2, this is J2, that is EB2 because it is a black surface. This is R1 to 2, isn't it? Then between 1 and 3, this is R1 to 3, this is J3. And there is another resistance R2 to 3. And one more resistance will be there, that is EB3 because third surface, this is R3, will be given by 1 minus epsilon 3 upon epsilon 3 A3. R1 is given by 1 minus epsilon 1 upon epsilon 1 A1. And then R1 to 2 is, this is how the circuit diagram will be drawn. It is 1 upon A1 F1 to 2. This is 1 upon A2 F2 to 3. This will be 1 upon A1 F1 to 3. So there will be 5 thermal resistance, and this is Q2. Q2. This is Q1. And Q3 will be equal to 0, isn't it? Because the third surface is insulated. So we can say J3 will be equal to EB3 is equal to sigma into T3 to the power 4. Even though the thermal resistance will be there, but this part of circuit will not be taken into consideration for the analysis because there is no heat flow in this part. Because of insulated surface, there is no heat flow. So the final curve can be this only. Is this clear to everyone? And from this we can say Q1 will be equal to minus Q2. This is Q1 to 2. This is Q1 to 3. This is Q2 to 3. Isn't it? So if we write, so from here we can say Q1 is equal to Q1 to 2 plus Q1 to 3. And Q2 is equal to Q2 to 1 plus Q2 to 3. And Q1 to 3 is equal to minus Q2 to 3. Because there is no heat going into this network. we can say Q123 is equal to minus Q223. Do you agree? Q123 is equal to, or Q123 plus Q223 is equal to 0. Q123 plus Q223 is equal to 0 for this node. Or we can say Q123 plus Q223 is equal to 0. So if we add these, and Q122 is equal to minus Q221. So Q1 plus Q2 will be equal to 0, or we can say Q1 is equal to minus Q2. This is how the analysis can be done. This is how the circuit diagram will be drawn when one of the surface is re-radiating or non-participating or refractory medium. Now the last topic for the day, that is the radiation shield. Why do we use the radiation shield? To reduce the effect of radiation. So the shields are used to reduce the effect of radiation, and they are mainly used where the effect of radiation is very large in high temperature applications. The shields are mainly used in high temperature applications like measurement of combustion temperature, measurement of flame temperature in nuclear reactors. What is the perfect radiation shield? Thin aluminum stripes, aluminum foil. We generally use aluminum foil. Why do we use aluminum foil? To keep our food warm. It is acting like a radiation shield. It reduces the effect of radiation. That is why the food will be kept warmer for a longer duration. In aluminum foil, the food is kept warmer for a longer duration. So thin aluminum stripe. Why? Because of its high reflectivity and low emissivity. That is the reason of using aluminum as the shield. Are generally used as radiation shield. Reflectivity is very large and emissivity is very low, so it will not introduce any heat into the system. Otherwise, if you take the radiation shield, the material which is having high emissivity, then it will also insert the radiation effect. So the radiation shields are used to reduce the effect, not to increase the effect of radiation. So the surface which is having low emissivity are very popular to be used as a radiation shield. Now how they reduce the radiation effect? They neither deliver any heat to the system or remove any heat from the system. They neither introduce any radiation to the system nor remove any radiation from the system. What does they do? They only place another resistance in the path of the heat flow, and when there is an increase in thermal radiation resistance, definitely the heat transfer rate due to radiation will decrease, because Q radiation is inversely proportional to thermal resistance for the radiation. So if we increase the resistance, the heat transfer rate by radiation will decrease. That is how the shields work. They only place another resistance in the path of the heat flow so that the overall heat transfer is decreased. Q is inversely proportional to thermal resistance, we all know. Even for a black shield, if we use a black shield, so what are the thermal resistance which are introduced in the analysis of thermal radiation? One is the surface resistance that comes into picture only when the surface is non-black, and the another is the space resistance that is due to the region between two surfaces. That is due to the space between the two surfaces. That is called as space resistance. Now, if we are using a black shield, then the surface resistance will not introduce into the system. Surface resistance will be 0. But how the total number of resistance will be increased? By introducing the space resistance. Even if the black shield is used, there is an increase in thermal resistance, no doubt in that, because of the introduction of space resistance into the network, reducing the radiation effect. I hope it is clear to everyone. All the points are clear to everyone. So let us talk about the analysis part now. We have already talked about the large parallel plates without shield. When the plates are very large, A1 is equal to A2 is equal to A, and they can be considered as the enclosure. So F1 to 2 is equal to 1. that is equal to F221. So if we apply that concept for large parallel plates without shield, this is the expression. There will be three thermal resistances. One is R1, that is the surface resistance, then R1 to 2, that is the space resistance, then R2. There will be three resistances coming into the heat flow network. This is how the circuit diagram will be drawn. This is R1, this is R1 to 2 space resistance, this is R2, and this can be called as Q1, this can be called as Q2, and this is Q1 to 2. That is equal to minus Q2 to 1. That is what we have already discussed. So if we put the values of A1, A2, then we will get Q without shield in watt as EB1 minus EB2 upon this expression. If we multiply or if we divide by area, this will be the expression. If we multiply and divide by area, this will be the expression watt, and Q dash will be equal to Q by A, that is sigma into T1 to the power 4 minus T2 to the power 4 upon 1 by epsilon 1 plus F1 by epsilon 2 minus 1. That is Q dash, that is the flux, watt per meter square. This is what we have already discussed without shield. There are two surfaces without a radiation shield. Is this clear? Now, if the emissivity, if epsilon 1 is equal to epsilon 2 is equal to epsilon, then Q dash without shield will be written as delta EB upon 2 by epsilon minus 1, isn't it? It will become 2 by epsilon, or we can write it as sigma T1 to the power 4 minus T2 to the power 4 upon 2 by epsilon minus 1. The unit is watt per meter square. If epsilon 1 is equal to epsilon 2 is equal to epsilon. So this is how without shield we can analyze. Now, if we introduce one shield, large parallel plates with one shield, what is the number of thermal resistances in this situation? Try to understand. These were two large parallel plates. Can you see them? Let me use some other. Look, these were two very large parallel plates. So the total number of thermal resistance was 3. One surface resistance for surface 1, another surface resistance for 2, and the third surface resistance for the 3. The third resistance is the space resistance between 1 and 2. If they are non-black, then there will be 3 resistances. But if they are black, then there will be only one thermal resistance. If they are black, then there will be only one thermal resistance, that is the space resistance between 1 and 2. Now, if we put for the non-black surfaces, if we put another non-black radiation shield, what will be the total number of thermal resistances? What will be the total number of thermal resistances? Can you just let me know? The total number of resistances? The total number of thermal resistance will be 6. Look how. Now, how? The first surface is non-black. It is insulated from this side. Surface 1 is non-black, so it can be treated as a black body with a cover. It can be treated as a black body with a cover. So there will be a surface resistance for body 1. It can be treated as there is a black body inside and there is a cover. So it will give you R1. That is the surface resistance for one EB1, and this is G1. Isn't it? Then there is a space resistance between 1 and 2. That is R1 to 2. This is R1 and this is R1 to 2. Then the shield can also be treated as a black body with a cover on both sides. That is important. There is a black body inside and there is a covering on both the surfaces, left as well as right. So it will provide two surface resistances. This is R3 towards 1 and this is R3 towards 2. Are you getting it? So there will be two surface resistance, R31 and R3 towards 2. And then there will be a space resistance R223. And finally, the last surface can be treated as a black body with a cover. Then there will be space surface resistance for surface 2. This is J1. This can be called as J3. This is EB3 and this is J3 and this is J2 and this is EB2. This is how the circuit diagram can be drawn, and Q122 remains constant because all the resistances are in series. So Q122 will remain constant. So if we analyze this, so delta EB is equal to EB1 minus EB2. This is delta EB. We can call it as delta EB divided by R equivalent. So that will give, so if there is one radiation shield, then Q122 will be given by this expression. This is R1, this is R122, this is R3 towards 1, this is R3 towards 2, this is R2 to 3, this is R2. These are the totals. So adding these together will give you the equivalent resistance. So this is actually delta EB upon R equivalent. This will be the expression. Now, because they are parallel plates, large parallel plates, F123 is equal to F223, A1, A2, A3 are equal to 1 because they are infinitely large parallel plates. So the equation gets simplified like this. This will be the expression. If you put A1, replace A1, A2, A3 by A only, this will be the expression. The unit is what? Now, emissivity towards emissivity 3,1 is the emissivity of the radiation shield towards one side 1, and emissivity 3,2 implies the emissivity of the same surface towards the other side, towards the two sides. Are you getting it? But if we assume the emissivities to be same, if emissivity 3,1 is same as emissivity 3,2, it is already mentioned, I think. So emissivity if emissivity 3,1 is equal to emissivity 3,2 is equal to emissivity 3, then the expression will be Q122 with one shield will modify as delta EB upon, it will become 1 upon epsilon 1, it will become 2 by epsilon 3 plus 1 upon epsilon 2 minus 2. This will be the expression, or we can say del, or we can write it as sigma into area also. Sigma into area into T1 to the power 4 minus T2 to the power 4 divided by 1 upon epsilon 1, 2 upon epsilon 3 plus 1 upon epsilon 2 minus 2. This will be the expression. This will be the expression, isn't it? And Q dash one shield can be written as, that is delta EB upon 1 upon epsilon 1 plus 2 by epsilon 3 plus 1 upon epsilon 2 minus 2. This will be the expression for flux watt per meter square. And if we generalize this expression for n shields, if we generalize this expression for n radiation shield of equal emissivity, that is epsilon 3, then our expression will be Q122 with the n shield will become delta EB upon, it will become 1 upon epsilon 1 plus 2n by epsilon 3 plus 1 upon epsilon 2 minus n plus 1. This will be the expression into area, that is watt. and Q dash 1 to 2 with n number of shield will be equal to delta EB upon this expression 1 upon epsilon 1 plus 2n by epsilon 3 plus 1 upon epsilon 2 minus n plus 1. This will be the expression watt per meter square. Is this clear? And what is n? N is the number of radiation shield. Look, this is the circuit diagram for all the surfaces to be non-black. All the surfaces are non-black. If all the surfaces are black, then initially there was only one single thermal resistance. If all the surfaces are black, then without any shield, the only thermal resistance is the surface resistance, is the space resistance between 1 and 2. Now, by introduction of a black shield, there is no addition of surface resistance because it is the black body. But instead of single space resistance, now it will become two space resistance. It will become two space resistance. So the number of space resistance will definitely increase by the introduction of radiation shield. That was the last point which I had mentioned. Now, if we talk about a special case, the special case is if emissivity of all the surfaces are equal. Epsilon 1 is equal to epsilon 2 is equal to epsilon 3 is equal to epsilon. If emissivity of all the surfaces are equal, then our expression Q122 for n shield will be given by this expression. Or we can say Q, this is 2 by epsilon minus 1. Q122 with n shield divide by, if all the surfaces are having same emissivity, divide by Q122 without shield or no shield will be equal to 1 upon n plus 1, where n is the number of radiation shields having same emissivity as epsilon. Same emissivity epsilon. Or we can also write, this is the expression, or we can also write in terms of flux. In terms of flux, what we can write, divide by area, we can say Q dash n shield divide by Q dash no shield is equal to 1 upon n plus 1. Is this clear to everyone? This is all about the analysis of the radiation shield. It increases the number of thermal resistances, so that is why it reduces the effect of radiation. Now, that is all from my side. Now, I am giving you a couple of questions, assignment question. This is question number 1. Try to solve it at home. And if you have any doubt, you can always raise your concern in my Telegram group. And also please do share your answers to my Telegram group. These assignment questions are important for you to have the better understanding of the concept. Another question is question number 2. I will share the PDF of all these sessions to my Telegram group. Do join me on the Telegram if you are not part of my Telegram. So these are 2 assignment questions, and do not forget to join us, me and Dheeraj Sardana sir, on 21st May. That is on Saturday at 11 AM for the Menti War. The topic for theory of machine is simple mechanism. We will bring 10 to 12 questions from theory of machines, and the topic for heat transfer is thermal radiation. To revise all the concept, it will also carry 10 to 12 questions, and all the question will be objective type or MCQs. So do join us with your full preparation, with your full motivation, with your full hard work, so that you will understand whether your preparation level is at par with the actual standard or not. That is all from my side. See you day after tomorrow at 11, and you can always contact me on the mail ID, or you can join me on the Telegram, which is the link is mentioned over the screen. Anybody is having anything to ask, please do let me know. Otherwise, let me take your leave with this motivational saying: work hard, dream big, and never ever give up. These are very, very important to achieve your goal with flying colors. With this motivational saying, let me stop here. Till then, enjoy, have a good night, stay safe, stay healthy, and keep preparing with BYJU'S Exam Prep. Thank you guys. Thank you for being part of this beautiful session. I hope you have enjoyed it, you have liked it. Do like the session if it improves your understanding of the concept. So thank you guys. Thank you once again for making this session